Hi everyone, in this video we are going to discuss about theorem number 19 from the geometry of circles. The theorem says, for a circle, if a secant line which intersects the circle at point A and B and a tangent line at point T intersect at an external point P, then PA times PB will be equal to PT squared. Let's suppose we have a circle like this as you see in the diagram, and we have a secant line that intersects the circle at points A and B, and I have named this secant line as L sub 2, and we have a tangent line which touches the circle at point T, and I have named this line as L sub 1. And these two lines intersect each other at a point P which is outside of the circle. And in this type of situation, the theorem says that the product of the length of PA and the length of PB will be equal to the square of the length of PT. So let's get started with the proof. For us to be able to do the proof, we have to do a little more construction. We have to create two similar triangles somehow, and then we can use the properties of similar triangles, and then we can prove the theorem. So what I'm going to do, I'm going to create one triangle first by joining the points A and T. So now we have a triangle PAT, and now I'm going to join the points B and T to create the triangle PBT. Now if we look at these two triangles, the triangle PAT and the triangle PBT, we can clearly see that the angle ATP will be equal to the angle ABT, and that's based on the theorem number 9. There we have proved that the angle between a chord and a tangent is equal to any inscribed angle for that chord. So angle ATP will be equal to angle ABT. Now also between these two triangles you can see that the angle BPT is a common angle between the two triangles, and I have called it angle beta. So we have two triangles where we have one pair of angles, they are equal, and we have a common angle. That means the third angle will also be equal, because we know that the sum of three interior angles of a triangle is equal to 180 degree. So for the triangle PAT, alpha plus beta plus theta is equal to 180 degree, and similarly for triangle PBT, there also if you see alpha plus beta plus theta, that is also equal to 180 degree. So that means the angle PAT will be equal to the angle BTP. So now we are able to prove that these two triangles have three pairs of interior angles, they are equal to each other. That means these two triangles are similar triangles. So I have indicated that with the sign of similarity there. So triangle PAT is similar to the triangle PBT. Now because these two triangles are similar triangles, let's now use the property of ratio of corresponding sides are equal. So we can write it like this. From the smaller triangle, we say the side opposite to the angle alpha, which is PA, and similarly for the larger triangle, the side opposite to the angle alpha, which is PT. So their ratio would be PA over PT, and that will be equal to the similar ratio of sides opposite to another equal angle. Now let's look at the angle theta. So the opposite side of angle theta in the smaller triangle, that would be the side PT, and then the opposite side of the angle theta in the larger triangle, that side will be PB. So PT over PB, this is the second ratio, and the third ratio would be the side opposite to the angle beta. For the smaller triangle, it would be the side AT, and for the larger triangle, it will be the side BT. So we can say that the ratio of PA over PT will be equal to the ratio of PT over PB, and that will also be equal to the ratio of AT over BT. Now from here, if we take the first part of the proportion, which is PA over PT equals PT over PB. So if we take this proportion and then if we cross multiply, we can clearly see that PA times PB will be equal to PT times PT. That can be written as PT squared. So now we can see that actually PA times PB is equal to PT squared, and that's exactly what we needed to prove. As you have seen in the previous two videos, in this video also we have used the concept of similar triangles to prove the theorem. I hope the proof made sense. Thank you for watching. See you in the next video.